For our intents and purposes, what is data or data? What is it? That's exactly right. All data is info. How do we portray it? We can put it on a graph, right? Okay. All data falls into two categories. I'm going to use fancy math words. You're going to figure out what they mean, okay? Data is either qualitative, or data is quantitative. What do those words mean? What word do you see in both of those words? Quality and quantity. All right. What would qualitative mean? A lot of data. Okay. Any other guesses? None? No? Okay. So, let's switch over. Quantity. What's quantity mean? An amount, right? Everyone agrees? Right? I have $60 in my wallet. Is that a quantity? Okay. If I were to ask you, do you consider $60 to be a lot or a little bit of money? What would you say? I'm asking you people. You are 15-year-old kids. How much money, cash, is in your wallets right now? So I'll ask again. Do you consider $60 in someone's wallet to be a lot of money to be on their person? Yes. Okay. So 60 is a quantity. A lot is what? Quality. Does everybody understand the difference? Okay. I had a good day at school. I was at school for 5 hours, which is qualitative. Good, right? Okay. Jaden and Malik were at school for the exact same amount of time, yes? Malik won a gummy bear. Who had a better day? Malik. Okay. Why? Because he won a gummy bear. That's a qualitative statement, right? Maybe Jaden hates gummy bears. And he's like, I want one anyway. Does the qualitative statement change for each person? Yeah, it does, right? Because Jaden couldn't care less, and Malik's like, yeah, I want a gummy bear, right? Qualitative changes. It's up to who to decide the qualitative parts of data. Who makes the decision? You do, right? Everybody understands? Okay. Quantitative is numbers. Is there a decision to be made there? There's no decision, is there? It's just a number. How many gummy bears did Malik win? 1. End of discussion. There's no way around that, right? It's neither good nor bad. Malik got 1 gummy bear. Jaden got 0 gummy bears. End of discussion, right? Okay. So, we're in a math class, right? Which one of the two do we care about? Quantitative. Why? Because it's numbers and we're a math class. In social studies or English or psychology, we might care about qualitative, right? But here, we only care about numbers. Everybody cool? Now, all quantitative data falls into 2 categories. And they're written on the top of the page. It is either discrete, and I'm not going to define these yet, or it is, I should have put continuous there because I'm going to run out of room. Continuous. Discrete. Spelled like it is on the top of the page. All quantitative data is one or the other. And we're about to talk about what they are in a moment. Everybody cool? All right. Let us now make a graph. Everybody read that question, blah, 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 blah. And tell me how many different, I don't want to say types, how many different pieces of data are in those two sentences, that one sentence, because we only care about the sentence, right? What's the data involved in there? That is quantitative, because we don't want qualitative data. What are the two things? So there's dollars. That's a number that's counted, yes? And, Jenna, days. Now, if we are counting two things and they are connected, they must be a relationship, yes? Possibly a function, yes? Okay. If they are related to each other, as they obviously are, then one must be a dependent variable and one must be an independent variable. Which is which? Days is independent and cost is dependent. Do we agree? Okay, and we all know why, yes? Why? Days is the time, and I've told you time is always the independent variable. But that's not the real reason. What's the real reason? Cost depends on the number of days I rent the car. Right? Everyone's cool with that? Okay. So if I was going to draw a graph needs two axes, x and y, yes? What goes on the x-axis? Days, because that's the independent variable. So there's my D. What goes on this axis? Dollars, my cost. And if I'm going to make a graph, I should draw it. I should title each one, yes? What's the title down here? Time measured in what? Days. What's my title here? I would say cost measured in what? Dollars, because I'm lazy. I don't want to write the word dollars. Everybody cool? Okay. If I rent a car for 0 days, I walk into budget, I look around, and I walk out. How much do I pay? Zero. If I decide, you know what, I like these cars, I need a car today, 1 day, my line's not working, you know what it's going to be. What's going to be here? 165. Agreed? Okay. What if I keep it a second day? I'm having so much fun, I keep it a second day. 130. Having so much fun, I keep it a third day. 195. Everybody cool? Easy peasy, yeah? Right? Okay. What happens on the fourth day? Goes up $30 instead of 65. So what's my cost or output going to be? Oh, it's the tough one, man. 195 plus 30. You can do it. 225. Nice job, Jacqueline. What about the fifth day? 255. What about the sixth day? 285. What about the seventh day? 315. Why must I stop there? Because I only have data up to 7 days. Does everyone agree? Everyone agrees? Okay. Let's put it on our graph. 1, 2, 3, 4, 5, 6, 7. Cool? And going up the side here, let's go up in 50s. 50, 100, 150, 200, 250, 300, 350. Do I have to write every one? No, of course not, because you can tell now that each click is $50, yeah? Everyone agree? Okay. At 0, how much money do I pay? $0, right? So my first dot has to be right there. Is it possible to have 0 and 0? Yes. Okay. Now, I walk into the budget at 8 a.m. when they open. I walk in and say, I need to rent a car. And he says, okay. How much do I have to pay now? $65. So technically, as soon as I say yes, I need to start paying, don't I? But it can't be at 0 because 0 is pay no money. So I got to have an open dot at 65, don't I? Everyone agree? 5 minutes into the day, how much have I paid? $65. How much have I paid by lunchtime? $65. How much have I paid by dinner time? $65. How much have I paid by 8 a.m. the next day? No, not by 65. So up to 1 day, I'm paying $65, yes? As is proven by the fact 1 was 65. Everybody cool? All right. I don't go back to the shop the next day. I'm having so much fun. I've driven up to Whistler. I'm having a good time. I met some friends. We're chilling. We're hanging. I don't want to drive all the way back to Vancouver. And it's 8:25 a.m. the next day. How much am I paying? 65. Except I've already paid 65, so I'm up at 130. Agreed? Open or close dot at 1 day. Open dot, because 1 day is 65. What is 1 second past 1 day? 130. So I do a line out to where? 2. Open or close dot? Close dot, because up to and including 2 days is $135. You all should be able to finish this off now, shouldn't you? Where's the next one going to go? Open dot at 195, which is a little bit below 200. Close dot, open dot. Now, will this distance be as long as this distance?
Yeah.
This one here, as long as this one here. Why not? Because I'm only going up by $30 at the 4th day, right? So I got to go up a little less. But then I go across the same way. Do I have 7 days yet? 1, 2, 3, 4, 5, 6, 7. Does everyone agree? Everyone agree? Now, if I were to read this dot or this graph, I would say, hey, how much it would cost me to rent a car for 5.5 days? Where would you go? You'd go out to 1, 2, 3, 4, 5. What's a half day? Right there, yes? And we'd go up the list, and what would we find? $255. Everyone cool? Okay. So, please notice I have 7 lines on the graph, yes? My next question says, should they be connected? Well, what are our options? Could I draw this line, this red line I'm about to draw? Could I draw that line? Prab says no. Some people say yes. Who wants to tell me why they said what they said? Everybody's cool with going yes or no, but explain it. Hell yeah. Okay, so we want our graphs to have a line on it, yeah? Okay, and they're very close, especially up here. Okay? Jacqueline, are you a yes or a no? Okay, why wouldn't I draw that red line? Absolutely correct. At 1.5, I would be paying that much money. Am I? No, I pay either 65 or 130, correct? So it can't be that one. Well, what about this one? What's wrong with that red line? We never pay that much, do we? We're going through dots that don't matter. They don't exist. So it can't be that one. Okay, what about these?
Yeah.
We're all a yes on that? Prab is still a no. Prab, you're kind of contrary today. Why would I not want to draw those?
It just doesn't look right.
Of course it doesn't look right. Something about that bothers you. Heather? Time can't stop. When can time be vertical? When? When you have a 1985 DeLorean powered by plutonium with a flux capacitor. And only then. So we cannot connect this line. Is everybody cool? So should it be joined? No. Why not? Well, the first reason, as Jacqueline said, you can only have specific costs. There is no way to pay any number other than these 7 numbers, is there? So even if my input is a half day, I still pay the full day. Does everybody understand? Right? If I have this line, that would mean if I was there, I'd pay that much. And that's no good. And what was the other reason that Heather gave us? 2? Time must always move on. Or to quote Metallica, time marches on. But none of you listen to Metallica, so it doesn't matter. And you shouldn't anymore. Metallica sucks now. They used to be so wicked, and now they're just lame and old. I don't understand why bands do that. They kick ass for centuries, and they decide, you know what, it's time I got a symphony orchestra to play my music. I don't know why. I didn't buy your music to hear a cello playing the bass line to For Whom the Bell Tolls. Anyway, that makes me angry. Is it a function, yes or no? Why? Right. Every input gives a unique output. Because no matter what I put in, 1, 2, 3, 4, 5, 6, 7, or any fraction of those, I only get one output for each one, yes? If I tell you I'm renting this thing for 6 days and 2 hours, how much do I pay? $285. I'm renting it for 4 days and 1 minute. $225? $255. Because it's past 4 days. Everybody understand? One input, one output function. Now, here's where we come to the crux of today's lesson. What is the domain? What is the range? I do my domains in blue. What is the domain? The independent variable. So what is it? Yeah. So 1, 0. Can I choose not to rent the car? So is 0 included? Yes. What goes here? T or D or time, something, right? I'm going to write time because that's what I named the domain, right? Up to what? Does it include 7? Can I have any number between 0 and 7? Yes. Can I rent the car for 1.12 days? Can I rent the car for 3 days? Can I rent the car for 3.675 days? So I can have any number from 0 to 7. Yes? Any number. Could I make the tiniest fraction in the world and still have it as an input? Yes. Okay, what's the range? 0. 65. Why am I listing now? Because there's only one option at each input, isn't there? The next one's 130, and then 195, and then 225, and then 255, and then 285, and then 315. Agreed? Now, what's the title of this page? Discrete or continuous data, yes? Which one of those do you think is discrete, and which one of those do you think is continuous? What? Range is continuous? Domain is continuous is your guess, Helia? Why do you think so? Time goes on. Not bad. Time never stops, yes? So Helia is saying this is our continuous. And some other people, so that would make this our discrete. She is correct. I don't 100% agree with her reasoning for it. She says, because time goes on. I agree with you there. Time does go on. But let me ask you this, Helia. How old are you? 16. Okay, how old are you going to be tomorrow? How old are you going to be tomorrow? The day after? The day after? The day after? Right? So if I ask you to give me a graph of your age, you're only going to give me the years, aren't you? So is that continuous, even though you're counting time? Once you're past 5, do you ever say, I'm 5 1/4? Do you ever say, I'm 16 1/2? No, you don't. Come on. Now, your nerdy math teacher, the day before his birthday, I'm 43 and 364 365th old. But that's only because I'm a nerdy math teacher, right? Now, in reality, do you always have an age? Yeah. So in reality, your age is continuous. But on a graph, you would make it to be discrete. Does everybody understand that? Everybody cool? Okay. Now, why then is the range discrete? That's what makes it the dependent variable. Why is it discrete data, do you think? Because I haven't given you the real definitions of discrete and continuous data. I'm asking you why you think, if that one's continuous, why that makes this discrete. For what reason? You are on the right track, and when you add in what Prab just said, you're going to have the right answer. What did you just say?
I said it relates to
specific changes, right? I can't have a value of any other thing, right? It's going to go from 0 to 65. Will it ever be 62 1/2? No. Everybody understand? Okay, so now let's talk about these. Discrete data. Discrete data is something that we can count. Please highlight the word count. And I'm going to use the same color because these different parts of the definition work together. Continuous data is something we can measure. Does everybody understand the difference? How many vessels for liquid are in my hands right now? 2. Count them. Agreed? How much space is between them? That's a measurement, isn't it? Because my nose can be at any spot along that line, can't it? But I can only have 2 cups in my hands. Do you understand? Everybody cool? All right. Here's another way I like to say it. Discrete data has, and I'm going to steal Prab's word, has specific values. Continuous data, I should have changed color there. Continuous data has any value, and then you have to make a qualification here. Any value, not within a specific, and this is going to get weird because I'm going to use a word that we've used already to mean something else, within a specific range. Now, I don't mean range like data range. Everybody understand? For example, I am 5 feet 8 inches tall, yes? Which means how far is it from fingertip to fingertip? 5 feet 8 inches, right? On a person that is of normal proportions, this is your height. Everybody cool? Which means, what is the maximum distance these two cups can be from each other? 5 feet 8 inches. Agreed? Can there be any measurement of distance between these two? Yes, but only within 0 to 5.8, or 5 feet 8 inches. Everybody understand? Everybody understand? Someone could come behind me, put their pointer finger anywhere on this line, and it would be a value that we could get. Yes? Now, if they put their pointer finger out here, past here, they're beyond this range. Yes? Everybody cool? So, let me give you another one that will help. Is the height of a human being continuous or discrete data? Continuous, right? But that doesn't mean it can go forever because we're stuck within the confines of human height, aren't we? The tallest human ever, I can't remember how tall Charles Wadlow was. I think it was 8 feet 6 inches tall. That's it. Malik is the tallest person in this room. How tall are you, Malik? 6'3". He is 2 feet taller than Malik. Malik, go stand by the wall. Just for fun. I don't care. He's wearing shoes. Stand right here. No, right against the wall. The tallest man ever, his head is there. That's it. Okay. Everybody understand? Tallest woman ever was 8 feet 1 inches tall. So, tallest woman that we know of. Now, you can go to the bathroom in a minute. Which means, even though height is continuous data, because every human being always has a height, and we could measure it down to the smallest fraction, even though we stop naming those fractions, right? There is still a range that is acceptable. It doesn't go from 0 to infinity, right? That's what makes it continuous. Everybody cool? Yeah? So if your data in your domain or your range can be any number inside that range, you have what we call continuous data. Okay? Everybody with me? Now, in this graph, do I have a continuous domain, a continuous range, or a continuous function? Once this question is answered, Tajri, you can do your bathroom or water run. Do I have a continuous domain, a continuous range, or a continuous function? I have a continuous domain, don't I? Because I have measured my domain from 0 to 7, and it can be any number from 0 to 7. I do not have a continuous range. I have discrete range because I can only be 0, 65, 130, 195, 225, 255, 285, and 315. Got it? Okay, go. Yes?
Do you have any real-life examples of a discrete?
Yes, we're about to do 4 on the next page. It's almost like you read my mind. Turn the page over. Given this data, tell me the dV, the IV, and whether it's discrete or continuous, and explain. So for the first one, I need an IV and a dV. So the first thing I have to decide is the two things I am counting. Then I have to decide which is which. Then I have to decide if it's discrete or continuous and why. Now, is it possible, when I say discrete or continuous, is it possible that I mean range, domain, or both? Yes. Everybody ready to do the first one? Prab says he's already got the answer. Let's give everybody else a chance, Prab. Or do you need to go to the bathroom too? Okay, chill. Give everybody else a chance. Because for whatever reason, you were kicking the crap out of this unit.
Can I go to the washroom?
When he gets back. Okay, everybody ready? What's your guess for IV and DV?
IV.
Malik. Because I bet you're saying what Prab just told you to say. Go, Malik. The IV is the speed of sound. The DV is the air temperature. Does everyone agree, or do I have a dissenting opinion? You think it's the other way around, hell yeah? Okay. Everybody ready? I'm going to give you a visual demonstration of what it really is. Now, I'm going to ask you to do something that this class has proved is completely impossible, but I'm going to try. Everybody ready? Nobody make a sound. No, see, you can't do it. I just said nobody make a sound, you started talking. Let's try again. Attempt number 2. Nobody make a sound. All right. In this room, while no one was making a sound, was there an air temperature? Yes. So which is the independent variable? Air temperature, because that's what's the same for everybody. IV is air temp. dV is speed of sound. Now that we've decided that, let's decide if it is discrete or continuous data, or data, depending on what you say. Is there, in this room, always an air temperature within an acceptable range of temperature? Yes? The coldest it could get ever in a room is negative 273 degrees Celsius. The hottest it could ever get in a room is however hot it is in the middle of a star. Could this room be any number from that bottom point to that hottest point? Yes. So is the air temperature discrete or continuous? Continuous. Excellent. Malik. Because at negative 273 Celsius, particles stop moving. And the only thing that makes heat is how fast particles are moving. Kinetic molecular theory. Right? If the particles aren't moving, there can't be any heat. Now, if you are measuring in Kelvin, that temperature is 0. The Kelvin scale starts at 0. I don't like that. I don't like Kelvin. All right. Funny. Yo.
Is that because you're a math teacher and you like wanting to be a number?
No, I just think, why would you ever start with an absolute? What if we find somehow that matter particles do something else other than move? Who knows, right? Okay, next thing. Does sound always have a speed?
No.
Yeah, it does, right? It's always, no matter what, this sound wave coming out of my mouth and hitting your ear has a speed. Can that speed be a fraction? Can it be a decimal? Can it be a minusculely small decimal? So within the range of speed of sound, from the slowest it can go to the fastest it can go, can it be every single value? So this is continuous.
But it will stop once you don't like
Yes. But if there is sound, it's got a speed. Right?
So both of them are continuous?
Yes, the whole thing's continuous. Everybody good? All right. Let's look at the second one. Go. I need the IV, I need the DV, and I need discrete or continuous and Y. Oh, I'll be writing the definition for the first one while you're thinking about the second one. All righty. What's our IV? What's our DV? 17 people talking at once. I need one person so I can get an answer, and then we can discuss it. Hell yeah, hit me.
Independent variable is female's age, and then dependent is whiteness.
Independent variable is age, and dependent variable is dosage. Who agrees? Who agrees with Helia? You're all right. Why?
Because if you don't have an age, you don't have vitamins. Like
Age depends on how much vitamin C you need.
Yeah, no.
Other way around.
Your vitamins.
Okay. Ladies and gentlemen, I know in this current era of gender fluidity, females, am I a female? Do I have an age? So what's the independent variable? Age, because it applies to everyone. Am I taking vitamin C right now? You don't know. I'll tell you right now, I am not. I could be, but I am not. But I still have an age. So, my age is the independent variable, the dosage is dependent variable. Think about it if you've ever read the instructions on some medicine. What does it say? If you're under 12, take blah. If you're over 12, take blah, right? The dosage depends on your age. Now, is it continuous? Is it discrete? Or is one of them continuous and one of them discrete? It's all discrete. Why?
It's specific to your age. Or it's something to do with that.
Because your age is not continuous.
The way I've written this question, is your age continuous, Helia?
Oh.
The way I've written this question, no. Why not?
Because for every year you get a different dosage.
For every year you get a different dosage. Remember that what we were talking about earlier? How old are you today? 16. So you take one vitamin C pill when you're 16. Yeah. Are you going to take, how many pills are you going to take tomorrow?
1.
Day after that?
1.
Day after that? Okay. In 10 years from now, you're going to be 26. You're going to change your dosage, yes? Because it goes by year. I don't have an input of anything except whole years. Does everybody understand? Yeah? Okay. So, because my IV is in whole numbers, it's discrete. Because age in whole numbers is counted, isn't it? Right? How many birthdays have you had? If you're 16, you've had 16 birthdays. Right? How many birth dates have you had? 1. Good, just making sure. Everybody understand why this one's discrete? And it's also even discrete on the dosage, right? Because you wouldn't take a razor blade and shave off a little bit of vitamin C every day from a pill to add up to the whole pill Right? Okay, good. Number 3. You sure? You're a bit of a flip-flopper.
I think I got it.
Should we let Prab answer?
Yeah.
See if he goes. Right now he's 1 for 2.
Okay, the IV should be cans of juice and the DV should be cost.
IV is cans, DV is cost. Who agrees with Prab today?
He always knows.
Is he right? Yeah, he's right. Of course he's right. If I go into Safeway to buy juice and I buy no juice, is there any cost?
That would be too bad. No, but the juice still costs the same.
No, I thought it was like, it depends on how many cans you buy.
Yeah.
That's what I said.
Yes. The cost depends on the number of cans I buy.
This guy, don't even listen to this guy. This guy is
Okay, Malik, you go to Safeway because Mrs. Malik says, go to Safeway and buy us 10 cans of juice. Do you understand? Okay. When you go to Safeway and you fill your little wheelie basket with 10 cans of juice, and you go to the cashier and you flirt with her because she's maybe cute, and it's a good move to flirt with the cashier if they're cute, because they're stuck there. They have to talk to you, right? It's a great move. No, Mrs. Malik meant Malik's mom. Not Mrs. Malik. He's 16. He's not married. Come on. Anyways, dude, the cost that the amount the cashier is going to take from you depends on how many cans are in that wheelie basket, right? If you walk up with an empty basket just so you can flirt with the cashier, will she take any money from you? No! She's a cashier. She's not an escort. Yes?
Basically, I thought the variable is like that is depending on something.
Yes, the dependent variable cost.
Mr. Myers, he knew he wanted to agree with us. He just didn't know what we said.
What I mean is like I was right, but I did put it in the right spot.
Okay. All right.
It's discrete also.
Now, Tushar, what you are arguing, yeah, but the cans of juice sitting on the shelves cost $1.98 each, right? Right? That's what you're saying. Doesn't matter whether you buy them or not. That's what it's going to cost. But the number of cans purchased is related to the cost. Once I take those cans out of the store, unless I'm a thief, what I paid depended on how many cans are in my bag. Okay? All right. So this one, continuous or discrete? Discrete. Why? Can't have half a can. I cannot go to Safeway, buy a can of orange juice that's frozen, cut it in half, make half the orange juice, take the frozen half log back to Safeway and say, I wasn't this thirsty. Right? Now, is it discrete? Domain, range, or both? They're both discrete. Because one can costs $1.98, 2 cans cost $3.96. Right? Discrete, both. Because you can't buy half a can. And lastly, IV, DV. This is so fun. Prab, you're 2 for 3.
The IV is altitude and the DV is temperature.
IV is altitude, DV is temperature. Do we agree with Prab today for him to go 3 for 4? Do we agree? He is 100% correct. Well, he's 75% correct because he went 3 for 4. Why is this one this? Right now, do we have a temperature? If I go to and do we have an altitude? Yes, we're about 30 meters above sea level, right? If I go to the top of Mount Baker, do I have an altitude? Do I have a temperature?
Yeah.
Which one's depends on which? Is it warmer or colder at the top of Mount Baker? Colder, because there's snow up there still, yes? There's snow up there all the time. So obviously, temperature depends upon altitude. Right? Okay. Discrete or continuous? Continuous. Why?
Because you have a different temperature and the altitude.
Okay. This is an altitude, yes? Can I have a measurement anywhere on it?
Yeah.
I am measuring the altitude, yes? Can I be at this fraction? Can I be at this fraction? Can I be at this fraction? This fraction? This fraction? This fraction? This fraction? Right. So it's continuous. What about temperature? Is there always a temperature?
Yeah.
Can we divide that temperature down into the tiniest fractions of a degree?
Yeah.
Do we?
No.
No, but we can, can't we? Right? All right, so that's continuous because both input and output can be any value within an acceptable range. What is the lowest altitude you can have? 0, right at the ocean. What is the highest altitude on Earth you can have? On Earth. I just said on Earth. On Earth. Mount Everest. Thank you, Tushar. Which is 8,813 meters high. So, between 0 and 8,800 meters, anywhere in that altitude, we would always have a temperature, wouldn't we? Even if we were only 1 nanometer off the ground. Other way around. The deeper you go, the colder it gets. So depth, temperature still depends on depth. But then there's weird spots, right? Like if there's a fissure down at the bottom of the ocean and lava is bubbling out, that water is boiling. And it's 36,000 or 12,000 meters under the water. But that's, right, because there's lava there. If there was no lava there, it would be freezing cold. What?
This is more a question for a meteorologist, but you might know.
Okay.
You know a lot. When we do our weather forecasts, do they round up or down in the degrees? Because
Well, if it's 0.5, then around.
Yeah. I'm not sure. Yeah, that's all they just do it like numbers.
oh, yeah, never mind. I don't know what I was thinking.
That's okay. Is everybody cool with discrete and continuous? Okay, now that's the end of the lesson. Now, you'll notice that the actual piece of information is not that complicated. Can it be every single number? Yes or no? But you can see the way it shows up is a problem. Yes? Now, don't write this down. I just want to show you something. Would that be discrete or continuous data? Yeah? No problem. Would that be discrete or continuous?
It's continuous.
It's continuous. Why? Because it starts here, it goes to here. Can I be every single input on the way? Okay. And in range, it goes from here to here. Can I be every single value along the way? Yes. Okay. Now, what if it was this?
That's specific. That's continuous.
Discrete or continuous? Discrete. Because do I have an output for this input? No. Does everybody understand? So on a graph, what does discrete data look like? Dots. What does continuous data look like? A straight line. Everybody cool? Now, let me ask you this. No. Let me ask you this. Altitude, temperature. Okay? Right now, outside, who's got their phone with the weather banner on it right now? It could tell me the temperature outside. I do, but I can't quite reach my phone. 12 degrees? Okay. 12 degrees. Okay? All right. Whatever. It's fine. It's fine. Who has enough data to check the temperature at the top, or at Hemlock, or Sasquatch Mountain, whatever the hell it's called now?
Temperature of what?
Temperature at Sasquatch Mountain Resort. It's over by Agassiz. It's the closest ski hill to here. 7 degrees. Okay. So Hemlock is approximately 1,000 meters, and it's 7 degrees. Okay, now wait. Can anybody quickly, what's the temperature at the top of Mount Baker right now? Has somebody type in Mount Baker? Oh, crap. Mount Baker might give it to you in Fahrenheit. I hope it doesn't. Fahrenheit is the worst. Fahrenheit is stupid. So dumb. What's the temperature at the top of Mount Baker? Anybody? What? 6 degrees? I'm pretty sure he's sure. And now Mount Baker, the ski hill where they'd be measuring that, isn't the peak. Right?
Negative. Oh, no. No, it's
Now I gotta look. Okay, apparently it's 11 degrees at Mount Baker. So I'm betting somebody screwed up Hemlock Valley.
I don't know.
Regardless. So, whatever. It doesn't matter. My point is going to be made. Say this is 2,000, and say this is 2. Okay? Now, what points do I have data for? At 0, how warm is it? 12 degrees. At 1,000 meters, it's 7. Oh, I'm going to go 0. I'm going to go up here at 12. At 1,000 meters, it's here, 7. At 2,000 meters, it's here, 2. Now, wait. My data is discrete because I've only been given 3 points. But in reality, isn't this continuous? Right? So we can connect the line. That's where this gets tricky. Everybody get it? Because there is always going to be a temperature at any given altitude. Everybody cool? Now, if I was graphing the orange juice ones, 1 can, 2 cans, 3 cans, $2 for 1 can, $2 per can. 1 can, $2. 2 cans, $4. Is there any price here? So even though it's going up in a nice straight line, can I connect it? No. Does everybody understand? Good, I'm done. You have work to do on page 295, which for you people is page, the page I told you not to do yesterday, page 160. 160 and 161 is your work. Now, the astute members of the class will notice what's the next thing on my list? Quiz 1, which means when could I give you that quiz? Any class after today. Why will it not be Tuesday? Because you're writing your cumulative. Okay? Now, you guys are intelligent young people. Would I give it to you Monday before we've talked about this actual work that none of you are going to do? No, of course not. I'll give you a chance to not do your homework before I quiz you on it. Okay? Okay. Class ends in 8 minutes. You are free to move about the room and start not doing your homework now. Get a head start on not doing it. Because that's what you're going to do anyway.